Hello everybody, I will start my today another coding practice. In this video, I will solve this question, mini stack. So in this question, I will design a stack, and that stack will support push, pop, top, and retrieving the minimum element in the constant time. And yeah, I will implement the mini stack class, which has push method in which I can push the integer element bar onto the stack. Yes, and also I have the pop method in which I can remove the element on the top of the stack. And I will implement the top, which I can get the top element of the stack. And also I will implement the get many method in which I can retrieve the minimum element in the stack. I see. And I must implement the solution in over one time, compressed it for each function. Okay, so I see. Yeah, okay. So in this question, I will implement the mini stack class. And it has form method, push, pop, top, and get min. Okay. So if I could ask question to clarify the question statement, what if pop method or top method is called when there is no element in this mini stack? And similarly for get min, what should I return? Yep, that's the first question I would ask if it were a coding interview. And from the constraint, I can find that methods pop, top, and get min operation will always be called on non-empty stacks. I don't have to take care of that case. Okay. Good. So now I will implement mini stack class. So basically, for push, pop, and top method, this is actually these are implemented in the ordinary stack. So basically, I can use the internal list for this, and I can implement push, pop, top in the constant time easily. Yeah, because all I have to do is that, let me think of the internal list. I can just push the element into the tail in the constant time, and also pop, I can do it in the constant time. And for top, I just have to take a look at the last element in that internal list. So all of them can be done in the constant time. However, for get min, this is the, something I have to take care. Yeah. Good. So let me think with some examples. Okay. Yeah, so when I code like this, so it should work in this way. Okay. Good. So I think, let me think it in this way. So I have the list, and I will pop, say, the 2. Then here, the mini, tag should be, the mini should be 2. And when I think of the 1, which is the new element, at this moment, this should be, the mini should be 1. And let me think, if I get the one more element 3, And in this case, the mini would be 1. And let's think I have 0 here. And at this moment, the mini should be 0. Okay. So that being said, the mini element in the stack is always unstrictly decreasing. Mm. Okay. So when I think of popping out the element 0, the mini element should be 1, like this. So obviously what I can do is think of another stack. I can keep track of the mini in the current stack. And when I have to pop out the element from the mini stack, I would also pop out the element from the you know mini yeah mini stack. Okay, so let me call it. So this one I would call it as the internal list, and for this one I would call it as the mini list. Yeah. Okay. So basically, when I pop up the element from the list, I also pop up the element from the mini list. But say when I push one more element into the list, I also push the many new element into the mini list. I just have to compare the current mini element in the mini list, which should be the top element, with the new element 0. And because 0 is smaller than the 1, so I would push 0 into the mini. Okay, that's it. So that being said, I will start the implementation. So I have to think if okay. Okay, this is how I push the menu list element in the menu list, and now I push the new bar into the list in this way. Okay. Now I remember the pop method. This is quite simple. I just have to pop the element from the internal list and also internal menu list. Okay. And for the top, I will return just head element in the no tail element in the served list. Okay, and for get mini, I just have to return the top of the mini list. Okay, good. So let me think of this with some example. So I will try to think with this example. Okay. So firstly, I initiate the mini stack with the empty rest and the empty mini rest. Then I push element 2 into this stack. So because self.rest is now 0, I just have to append this element to mini rest. So now 2 is appended. And also I will append 2, bar which is 2 into the rest in line 34. Okay. The next thing I will do is I push number 1 again. So in line 28, because self.rest is not 0, I go to line 31. And the new min is the rest element is the mini rest, which is 2, and bar, which is 1, minimum of them, which is 1. So 1 is appended to the new mini rest. And also in line 34, I append the bar 1 into the rest also. Okay. Then in line 5, I will try to call the get min. So in line 45, I return the rest element in the mini rest, which is 1. Yeah, so line 5 is okay. So I will take a look at line 6 and I pop up the element. So in line 38, I pop the element from the rest and also pop the element from the mini rest. Okay. So now both of them have only 1, no, only 2. Then in line 7, I call the get min, which is in line 45. I return the tail of the mini rest, which is 2. Okay, good. So I think I've covered all the lines in my implementation. So I'm pretty confident in my code. So let me execute. Good, and I will submit it. Okay, accepted. So all the operations should be over 1 at the constant time. Okay, I will quickly wrap up my today's practice. So today I solved the question mini stack. Yeah. And this was a question to implement the stack, which has push top and push pop and top, which, yeah, actually the ordinary stack is implemented with, and also it has get me method. So this retrieves the minimum element in the stack. So this is a kind of new method, rare method, which should be implemented in the stack. Yep. So to implement this data structure, I internally use the rest and also another rest, which is named mini rest. So rest is just, pop and push I will pop and push the element to this rest, just like it's a stack. It's okay. And mini rest is used to keep track of the minimum value until each element in the stack. Yeah. So mini rest always has the same number of elements as rest. Yeah. Okay. So when I push the element in the rest, it should be also new minimum number should be pushed into the mini rest. And also for pop method, I should pop out the top element to the rest and also from top element for the mini rest. Yeah, so that's how it works. Okay, so that being said, I finished my today's coding practice. Thank you so much. Bye.